Good morning, class. Today we're going to talk about how to do a sheet metal part inside Solidworks. First thing I always recommend after you've opened it up, the software that is, and you're in inches, pounds, seconds, you're in the correct units of measurement, I always recommend you turn on your planes. This is a rule of thumb so you know where you are. Okay? A sheet metal part isn't that different from a regular part, other than the fact that you're going to start using the sheet metal toolbar. For those of you that like to have that toolbar on up front, you can actually move your mouse to this gray area on the screen. Right mouse button, and sheet metal is, this is in relatively alphabetical order. It's over here by sheet metal. Then you have your toolbar right there on the side. Okay, that's one way to do it. You can also turn it on later. That's up to you. If you click on base flange, the first thing it wants to do is create a sketch. Okay, that's the way I would do it. Again, base flange, the icon you want to click on. This is the way I would build it. I'm just giving you an example. You'll click on the plane you want to build it on. The reason I'm picking the top plane is because this is on the top plane, right? This is the right side. If I look at this part, I'm trying to write with my mouse, so that looks better than my own handwriting. Is that correct, or did I do something wrong? Is this right? That's right. That's correct. That's wrong. Got to use the right word. This is the front. Oh, wow. There we go. Front. This is the front of the part. That's the top. And then the right side's over here, but I don't have a place to write right neatly, so I won't. But that is why we are picking the view we are. The base of this shape is here, this piece of it. So that is the method to the madness for why, I know that's a very bad rectangle. That is the reason why I'm selecting the top plane to start with. Because this is literally right down here. This is the base of the part. Okay? That is the only reason I'm selecting to start there instead of starting on one of the flanges. So here I am over here. I click on there. Now, rectangle can be done a couple of different ways. Because this part has symmetry and its basic shape, you have this shape and then you have the wings on the side, the flange ups. That is why I'm selecting center rectangle. Okay? It'll be recorded for the 1,000th time. I'm lazy. If I can save myself some work later, in this case adding planes in to use the mirror command and whatnot, I'm going to do it. So if I use center rectangle, I have that option. I don't have to create a plane later to mirror my one wing over to the other side. Then I drop in my dimensions. You notice I switched to isometric for this purpose. Why? Because then I could see where the front is and where the right side is, so I don't make a mistake. So the front to back dimension, or the left to right dimension, the front of the part is 6 inches. The right side of the part, remember I picked the lines to dimension with, not a line or points. Remember that as well. Those are efficient ways to dimension for long-term use of the part and how you control it. 8 inches is this length. There we go. I hit OK. And I have OK out of it. Now I have the dialog box for material thickness, which is important. If I have material sheet metal parameters, if I turn this on, it means I have some type of table that I'm using. In our case, we do not. Okay. If I have a gauge table, I can select it. In the table I would use, there's a bend allowance inches. This is like a standard table that comes with the software. that you would utilize, or you can have a custom table at your company, wherever it may be. Then gauge material, sheet metal parameters. For those of you in my welding class or my sheet metal class, we talked about gauge all the time, what kind of thickness. Steel air bended is the process that's selected here. Perhaps that's not what you want. Bend deduction in inches. There are many bending processes, so this gets really, really picky with what type of process I'm using. All the different gauges, these are the ones that are in the system. If I don't want to use a bend chart because I don't know which process, I'm taking a more general approach. If I'm going to use this product for designing stuff in the shop, I want to know what my build parameters are from the shop. Most companies will have that by default. But if you're starting your own business, obviously you don't. So you got to do a lot of research to make sure you do this correctly. In our case, I'm going to turn this feature off because I don't want to start doing sheet metal design 101. Different class, not here. Now, sheet metal parameters, what is the thickness that I plan to use? 0.125 is the thickness of my material. See that? See? And then if you zoom in on here, it'll show you. And you can reverse direction. Remember that? Flip. I don't care what you do there. I'm just showing you that it does. Cool? Okay. Bend allowance, 0 inches. Okay, that's good. I tend to pick K-factor. Okay, K-factor is a standard rule of thumb we use in the field when we're sheet metal bending. Half the material thickness, 0.5. Is your bend allowance, is a typical term. Otherwise, you break the material, okay, or you stretch it. Depends on what happens. You either rip it or it'll stretch, okay. Typically, that K-factor is allowing for a gentle bend. You can draw die a bend, but that's another conversation. Again, this isn't going to be sheet metal class, but I do prefer to pick K-factor in the bend allowance. Auto relief, it's fine. I don't worry too much about that, but definitely the K factor. I'm going to zoom out. When I hit OK, there's my base. It's all about the base. Remember that. Next, I want to create my bends on the side. I know it only gets worse. Only gets worse. So when we look further down, we have a lot of neat options in here. The one I'm going to select at the one I'm going to select is edge flange, because that's what I'm creating. When I click on edge flange, all I really have to do is click on the edge, hold my left mouse, there you go, hold my left mouse button down, then it holds it, then I let go of it, and I can move with my mouse and I can actually elevate it up or down. There are 2 arrows when you do this. The top arrow is dragging the size, the height of my flange. The bottom arrow, and the only way to show this clearly is to do a right side view, is actually defining where my bend is. Where is my bend? Meaning, if I scroll down on the right side of my options, see your flange location. Is it going to be to the inside of the metal, to the inside of the bend, to the virtual sharp point, or some other spot? Okay. The default in this case, because the edge, this is a 90-degree turn, so mathematically it works out that the virtual point and the outside edge of the material, they call it the material inside of the line, happen to be the same. Okay? That's where I wanted. The height of the flange, now that's under debate. If I go ahead and orbit this way, the height of the flange, we can debate the height all day long. We can say, oh, we're just going to go to here, all right, to the 1.5 inch mark. And then other people will say, I want to go to the absolute top. I honestly don't care which method you use. It doesn't really matter. Because what you're going to do is you're either going to add material to your flange, or you're going to take material away from it. I'm going to take the build it up first and then whittle away at it, a whittle at a time approach. And for this lecture, just to do it. So I'm actually going to build this shape. Now granted, I stopped at the 6-inch because I have no choice, right? And then I'm going to tackle adding on this piece as the secondary step to the flange. All right? My first step will be build a rectangle up, the complete height, and then add on this little tab at the end. So the height is a whopping 2.25 plus, remember you could do math inside here, so don't pull out a calculator. This is the radius right here of 0.75. 0.75. Okay. Then I hit enter. So that's a total height of 3 inches. Yes, I could have just typed in 3. I just wanted to show you the math, that you can do it in the product. And then I hit OK. So there I have my one flange. I can go to that flange and actually edit the sketch that the flange is created from. When I edit that sketch, now I have the option, I do normal too. So I can go ahead and add to this. Of course, you know, being who I am, I'm lazy. I'm just going to go ahead and draw a rectangle at the end of this, right? Instead of 3 lines. I'm going to draw a circle, midpoint to edge. And then I can keep it as crude as this, or I can trim it up and neaten it up. I'm going to leave it like this intentionally just to show you what you have to do when you leave it this crude. First off, I'm not going to be able to get radius automatically. I'm stuck with diameter. I don't like that. Why? Because one of the things I taught you guys in a previous conversation is every dimension you drop in here in your model, it translates directly into your detail drawing. And if you do it well, you can actually control your model from your detail drawing using your dimensions from your model. So you want to have the dimensions in your model that make sense. So I do recommend you trim at least a part of that circle off to make this piece a little easier so you get the correct kind of dimension so it comes out as a radius. 0.75 is a radius, so that came out fine. The distance from here to here needs to be 2 inches. That worked out all right. And that's all I'm going to add, because we're going to take the whittle away approach. So I'm going to chop off this piece. Let me change colors here. This piece I'm going to actually remove later, all right, as part of a separate operation as a cut. So I'm basically going to make literally the basic geometry. Let's see, what am I missing? I am missing the I could throw in the position of this object. 2.25. So I drop that down. Did this make this 3 inches? Yep, that's still 3. Now remember, when you're starting to get ketchup and mustard, in this case I'm getting mustard, as I call it because it's yellow, that just means you're making a driven dimension. You're okay, just appreciate that's what it is. And remember, driven dimensions are a light gray, whereas driving dimensions are a solid color. Okay? Next, you'll notice that it is confused. See how that's, some things are identified and this piece is not. When it comes to extruding, not extruding, are you extruding? You're not. You're just okaying out of it. You get a nice error message because it is confused. So stop and repair it. So the question is, what's wrong? The sketch. The sketch is wrong. I was too sloppy. Remember how I said you might be able to get away? Oh, I think I said you can get away with, so I'm wrong, which I like saying. Yes, it's on video. I have to trim out these entities because they're actually fighting my ability to build this part. Wow, look at that. It's got two little lines. Now we're back to something reasonable. But it did give me an error message, something about something not connected correctly. Something's, yeah, so let's find out. Now, my method of testing this out has always been wiggle it, take apart, wiggle it, see what's going on. Aha, there we go. There's something going on there. So this needs to be closed, it looks like. It's not closed. Something is in the way there, so let's find out what's in the way. Okay, this converted for some reason to a construction line. Remember what I told you? SolidWorks is subtle, annoyingly subtle. So I'm going to have to, I don't know why I did that on the fly. Switch that back. Now let's see. I'm going to maximize the screen real quick. Look at that end view. Does everything look right? No, something's off. Over here, something's off. So we're going to have to make sure these objects are tangent. Remember how to do that. Pick the object, hold your control key, pick the other object. Then you get your options for tangency on the side. Pick the object, hold your control key, pick the other object, and tangency. And you hit OK. So now this is starting to take shape. It's looking better. The only issue I think we have is, whee! I can take it out. I'm going to pull it all the way out here and drag it back in. So the locator is missing, which is the location, how far is that tab sticking out of the part? And that's on our drawing. Our customer told us that. This is what they told us. They told us 2 inches. So we go back in here, drop that dimension in. And voila! We're ready to rock and roll. We okay out of this? No error message. Everybody's happy. That is how you add elements to a flange. You edit the sketch of that flange. That is how you do it. You click on the sketch and you edit that. What's really cool, why use sheet metal, somebody might say. I can just build it faster if I just extruded it, made a U shape, extruded it out, cut it up, and be done with it. Well, if I did that, then I couldn't do this. Down here is flat pattern. If I roll this forward, see there? And, uh-oh, am I too far away from it? I should be able to do this. Click on flat pattern and unsuppress it. I actually get a flat pattern. That's the whole point of the sheet metal feature. Is I can generate a flat pattern for myself out of a model. Then when I go back, I can see my model in its finished state. And then if I want to, again, I can click on flat pattern and unsuppress it. And voila! I have the flat pattern that I can then send to a plasma cutter, a laser, a printer, and print it out and manually cut it out, whatever it is I'm doing. Got it? Whatever method I'm going to build this in. Again, always remember the alpha and omega. Here is the alpha where we build the part, but its ultimate goal is the omega where you literally build the part physically. So always think of what am I going to do with this. The purpose of all this software is to help you build, not play on a computer and make pretty pictures. Okay. Next, I've got one side done. I can do the other side if I want, or I can slice it. I'm going to take out this piece now. I'm going to do this instead. So it's 6 to 1/2 dozen. Doesn't matter which order you do it in. I'm going to pick this face, create a sketch. No, I picked edit sketch. Bad answer. Pick the face, create a sketch. Remember, the little star means it's going to create a sketch. There's a little pencil it's going to edit whatever it is. These are all edit features. The little star means I'm going to create a sketch. Remember that. So now I'm going to create a sketch. I cannot see any dimensions anymore, so I've got to erase all my little scribblies. There we go. So it looks like 76 degrees, an odd angle. So I'm going to draw a line out here anywhere just to draw it. And I'm making sure it's a closed loop. That's important to make sure it'll work. All right. Now I'm going to go to normal 2, which is the view that I want to work with, normal 2. I'm going to identify the smart dimension from here to here, bottom of the part. That dimension is 1.5. I don't have a length, but I do have an angle, so now I'm going to drop in the angle dimension. 76 degrees. One of the things you're going to learn by doing this, 76 degrees, yeah, is that this line, and I'm going to show this to you intentionally, that cut extends past this piece. So this piece here, let me erase a few things. When we're looking at the shape, I know it's subtle, this edge does not align with where this gets cut. You'll see that. It extends a little past it. Okay? So if anyone assumed that, you assumed them properly. Sorry. Now I threw that in as a construction line. You notice that? That way it will not interfere with me building this part. That's there purely for reference, just so you see that it does not perfectly align. Okay, next we go to features. We cut. What's nice is all you do is cut to what? The way that I like to say, length to thickness. That way, if I ever change my material thickness, my cut changes. Get it? You always want to do that, especially if you're working with sheet metal parts. Then you hit OK, and we're done. Lobbed it right off. Next step, I'm going to do the hole on the end. Remember the hole wizard, never pick the command first. Always pick the face that you're going to work on. Always pick the face. I clap my hands as a reminder of that. Pick the face first, otherwise you'll be very upset with yourself, because hole wizard does not work very well unless you pick the face first. Okay, it's a through hole, 0.625. So we're going to go with inches, fancy inches. Drill sizes, 0.625, 5/8 is what that is. Remember your fractions, 5/8. If you don't, you can always show your values in decimals next to them until you nail it. I'll always turn that feature on. That's a 6. Yeah, we had that conversation already. That's a 6. I know. It kind of looks like a chopped off, but that's a 6. Always remember, SolidWorks doesn't tell you what the next step is. You have to know. Pick on position. Remember, if you want to find the center of a circle, go to its edge first, then find the center. Don't try to hunt for it. Keep it simple. Now, back to type. One thing I didn't show you. See how it went all the way through that way? Instead of through all, do you have a choice of attached to material thickness? You don't. I'm going to pick up to next, just to avoid any snafus. Up to next, it will go to wherever the end of that thickness is.
Couldn't you draw the other side and just put a hole through both?
I can, but that's not how we physically would build this. I would punch everything out, laser cut or plasma cut, whatever it is, in the flat. I would never add a hole when after it's formed unless I made a mistake. That's a bad move from a production perspective. So when I hit OK, Again, remember the alpha and omega. I go back to my flat pattern and I unsuppress it and whammo, that's what I want. I want that hole to be part of this pattern, and that's how I achieve that. That's important because this is what I want to send to my plasma cutter, to my CNC, whatever. Cool? That's important because otherwise it's just a pretty picture and it's of zero value in production. And we don't CAD for fun, we CAD for production. Next. Teacher's lazy, so here it goes. At this point I could, let's see, how shall I do this? I could mirror the other side, but instead what I'm going to do is add this slot in, so that way, but is it correct? Do we know if it's, it might not be. We don't know if this 4.5, if this distance is identical on this side, we don't know that, do we? So we're not going to assume, because we all know what assume stands for. So instead of presuming that it is actually symmetrical, the slots, we're not going to. Okay? We do know these work together, but we're not going to presume that the slots do. So what we're going to do instead is we're going to mirror this. That we can do. And the best way to select the items you're going to mirror, now of course, remember what I told you about Solidworks. You kind of have to pay attention to the whatever's blue on the left side. So mirror face plane, that's center plane. Features to mirror, it's sometimes hard to pick everything, so I always say open up the model tree and select the items you're going to mirror. This item, and the flange. Got it? Select them all. When you hit OK, voila, there you go. Again, test, unsuppress the flat pattern, voila. Ooh, something happened. Did I miss something? Of course I did. So I have something that I missed. So let's see. So let's go back and fix that. I'm going to go to mirror. I'm going to edit the feature. I forgot the cut. It's easy enough to fix. I hit OK. Voila. There we go. That's it. Remember that. Anytime you're like, oh, wait a minute, I missed a piece. Just go back, click on the item, edit the feature. Anytime there's a pencil attached to a little icon, that means it's an edit of that item. That's all you got to remember. So nothing, you don't have to start from scratch again. That's not the answer. Now, the last step is putting in these slots. So I'm going to pick this face. And I'm not editing the sketch, I'm going to create the sketch onto that face. So I go normal 2. And then I prefer to use the straight slots right here. The straight slot is perfect. This can get visually annoying, especially if you're trying to do half a screen like I am, so you can just minimize that. And then literally that's the center line, and then that's the shape. Okay, that's the center line, and that's the shape. To draw them together, I'm drawing them together. It's okay. You can draw them separately. That's a choice. The distance between these two is going to be 4.5, not 5, 4.5. Okay? The distance from here to here is 5. The distance from this side to this side is 0.5. The distance from the center to the outside edge, that one's tough to see, but it's there. The outside edge, I'm going to put it on this side, okay, is 1.6425. That one edited beautifully, but this one didn't do anything, so how can I fix that? Let's see. Oh, this is not clean. Look at that. This moves around. What am I missing? I'm missing a dimension. I am missing the distance from the back wall to the center. I'm missing this dimension. and it's 0.4034. That's an odd number, but it's there. So that one looks good, but the other one didn't update at all. So the way to fix that, a couple of different things to think about. One, you can use your center line, so that way you have these two hooked to each other, and you take the center line, which is a construction line. That's the same object and the same line type is used in Solidworks. Pick vertical, that's how you attach the vertical position. The rest you can always do, click on the object, hold your control key, click on the object, and you can say equal slots. It's in the video. Equal slots. Okay, I'll show it again. That's what the rest of you heard on the video. Okay, again, pick the object, hold your control key down, pick the other object, since they're both slots, and then you have equal slots as an option. Whatever relations you can attach to the two objects you've selected, all those relations will appear. In this case, the equal option, which is really nice. Okay? And then you hit OK, and then you're good to go. Then you go over to Features, Extrude Cut, Attach. It automatically references to the thickness because I selected that earlier. Hit OK, and you are done. Again, the beauty of this is it's perfectly tied to a flat pattern. Undo that. That way you can send that to your machine to go ahead and laser it, burn it, whatever method you're using to cut it. And you are done as far as the modeling piece. And that's it. That's how you use this tool. It's a beautiful tool. Next time I'll show you guys how to detail it and also include a flat pattern in your detailed drawing. And that ends this video.